Hi, in this video we're going to learn the last chapter, which is chapter polymer. So in this video I'm going to explain just the introduction about polymers. Okay, so I'm going to cover this one, which is explain the terms monomer, polymer, homopolymer, what is all this, and also give you the examples of natural polymers such as protein, carbohydrate, and natural rubber. Okay, let's start. So when you learn about polymer, there are a few terms that you need to know and you need to understand, such as what is monomer, polymer, homopolymer, copolymer, what is stretch chain, and stretch chain polymer, and what is cross-linked polymer. Okay, so basically monomer is the basic molecular unit. Okay, the one that we repeat, the one that we use to build up the polymer. Okay, now to build up the polymer, to make the polymer, the monomer will undergoes the polymerization. Okay, where all the monomers will be combined to form the polymer. Now, if I can give you in if I can illustrate in other ways. Okay, now we have here a brick house. Okay, a brick house, and all these bricks are monomers. Okay, all these bricks are monomer. Each of the brick is the monomer. So we use all the monomer. We combine them to form a brick house. So all this we call as polymer. Yeah, if I can make the analogy, that's the words I'm looking for. Okay, so monomer is like the brick, and you build up the brick and you get the house. So the house is the polymer. So like for example, in this example, as you can see here, our monomer is ethene. Okay, so this is our monomer. Now from this monomer, we can produce the polymer. Okay, we can produce the polymer, and it undergoes actually this ethene, since it has double bond, it will undergoes addition polymerization, where in the end, okay, after the addition, okay, you're going to get the repeating unit where the double bond is break up. Okay, so this is the repeating unit. This repeating unit means the unit that will be repeat and repeat in the polymer. So our polymer, as you can see here, CH2, CH2, CH2. So those CH2 is this, CH2. Then it repeat again, CH2. Okay, so this is what we call repeating unit. So the monomer will be So the polymer will be like this. Okay, and we have to put N. N means it can be numerous, it can be I can say it's numerous, means banyak. Okay, it will repeat and repeat and repeat. Now this is the polymer. Okay, we have two types of polymer. We have homopolymer and we also have copolymer. And in terms of structure, we have two types of structure. We have straight chain structure, and also we have cross-linked polymer structure. Properties, we have two types of properties. We have the natural and we have synthetic polymer. So let's see what all these things are about. Now, homopolymer and copolymer. Homopolymer means a polymer formed from the same type of monomer. For example, we have a monomer A. So you can see that the repeating unit will be A. Okay, you can see it like this. Okay, so this is homopolymer. It only comes from the one monomer. But when we say copolymer is a polymer formed from two or more different types of monomer. So as you can see here, we have A, that is the first monomer, and we have B as the second monomer. So in this example, we have two types of monomers. So it can be AB, 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 AB. So this is copolymer. Okay. Now That's about types of polymer. Now let's take a look at the structures of polymer. Now, as I mentioned before, there are two types of structures for polymer. We have the straight chain polymer and we also have the cross-link polymer. Okay, so usually for the straight chain, it's just like a straight chain. As you can see here, this is a straight chain. It can be recyclable, it is soft, and it can be reformed again. Okay, so that is the characteristic of straight chain polymer. However, for cross-link polymer, okay, it is not a linear polymer. Okay, it has a link here, as you can see here. Okay, it has link, and because of this link, it is harder. Okay, it is harder. It is more elastic and cannot be remolded again, which means it is not recyclable. Okay. So usually, okay, in other forms of illustration, we can see that the straight chain is like this. Okay, we can see it like this. But for cross-link polymer, we can see it has link. This link makes it harder, makes it firmer. Okay. And you can see this is also another examples of straight chain. Okay, you can see here. And this is also a massive cross-link polymer. Okay, so in other words, if you look at the what we call this cross-link polymer, it has like a bridge between the two straight chain polymer. Okay, and yeah, we have two types of polymers in terms of properties. We have natural polymers and we have synthetic polymers. So natural polymers is it is naturally, we can get it naturally, it is already here, God made them. Okay, so again, it is found naturally. So the example is protein, carbohydrates, and also natural rubber. What is natural rubber? The one that the rubber you go to potong getah and then you get the rubber. Okay, so that is it. But when it comes to synthetic polymer, it is a polymer prepared chemically or human-made in industry. Okay, so to have this synthetic polymer, we are going to undergo two type of polymerization, which is addition polymerization and condensation polymerization. And these are the example for addition polymerization and condensation polymerization. Or I can say this is the example of synthetic polymer. Okay, so natural polymer, okay, you can see the example here. It's like protein, carbohydrates, and also natural rubber. So if you remember in the previous video of amino acid, okay, protein is actually considered as natural polymer. Okay, so protein is made by more than 70 amino acids. So this is it. Now, if you have a question like asking you, for example, like this, we have alanine, and we have this amide bonds. If the question asks you what is the monomer, so this is the answer. Okay, so this is the answer. And what will be the repeating unit? Okay, the repeating unit, since it is the same monomer, so they will usually remove the H and the OH. So the repeating unit will be in H. Okay, this will be the repeating unit. So your polymer will be this one. Okay, so don't forget to add N, because polymer means it has lots of repeating units. Okay, numerous, but repeating unit, you just show one repeating unit. Okay, so this is example for protein as a natural polymer. This is carbohydrates such as starch. Okay, do we need to memorize the structure? No, we don't need to memorize it. Okay. Alright, and also natural rubber. Okay, natural rubber. So this is, as you can see here, we have isoprene, which is the one that you can get when you tap the rubber tree. Okay, so the monomer will be, okay, so usually this will be your monomer lah. Monomer, something that before any process happen. Okay, before any process happen. So repeating unit is the structure after the reactions of polymerization. So for this one, usually will be like this. I'm going to explain more about this later. Okay, so this is the repeating unit. So as I told you, I'm going to explain later in the next video. So the repeating unit will be the same. Copy. So we just paste it here, but do not forget to add N. So that will be polymer. Okay.